Welcome back to Pre-AP Chemistry, Thermochemistry Flipped. Thank you so much for your patience with the technology. If this turns out to be a better learning process or learning method for you, I will kick up the technology a good notch or two. Now, we were on page 2 of your notes talking about heat. Now, heat is given the symbol Q, the lowercase q, and references thermal energy. This is key. Heat is a transfer of kinetic energy from a substance at a higher temperature to a system or a substance at a lower temperature. So when you touch a substance and it feels hot, it's because of the transfer process going on. And that transfer of energy is known as heat. Now, this is key. Heat is not a property. Heat is a transfer of energy. So if we have a system at a higher energy state, higher kinetic energy state, higher temperature. Temperature is a measure of average kinetic energy, remember. We get a flow of energy called heat to the lower energy state and the lower temperature. Now, we're going to be looking at ways to measure heat ultimately, but before we do, let's look at ways to transfer heat. I had hoped to get this part completed before tax to help you on the tax test, but unfortunately that didn't happen. The 3 primary ways are convection. You notice in convection there's some movement going on, and we'll talk about what that movement is in just a moment. Conduction, and you see there's direct contact here for conduction, and radiation. So 3 types of heat transfer that we're going to be talking about. Let's start with conduction. So conduction is going to have to happen when we have molecules or items at a very close proximity, and when that happens, we get direct transfer of heat via conduction. All right, the objects have to be at different temperatures in order for that transfer to occur, and the substances have to be in direct contact with one another, as we might have this direct contact with the hot spoon and the liquid or the hot cup. Now, this is going to continue until the 2 objects reach thermal equilibrium. So thermal equilibrium is when the heat transfer ends because you now have both or all objects at the same temperature. So we would call that thermal equilibrium. All right? Now, this is great if you're talking a hot pad on your hand, but it's not so good if you're talking about touching the surface of a stove that's really hot or the top of a Bunsen burner in the lab. Now, the next one is convection. For convection to occur, you have to have movement of molecules. Now, solids don't have that movement of molecules. So we're not going to see convection in solids. We're going to see convection in fluids such as a liquid or a gas. And what happens is this. You get the transfer of heat energy that heats the molecules near the source. The density then goes down and they rise to the surface where they're further away from the heat source. And so the density increases, they become more dense, and they sink. And when they sink, they get close to that source of heat, and you see the rising and the sinking due to the difference or the changes in the density. So that's what convection is. And again, this is not in solids. This is what you're going to see in liquids or gases. Now, the last one that we're going to talk about is radiation. Radiation is transmitted in the form of electromagnetic waves. Electromagnetic radiation, we talked about that way back in the atom unit if you'll remember, EMR, and we had a lot of formulas for that. Now, when you think of infrared goggles, we're looking at radiation being emitted as heat is transferred from warm bodies. And that's how we have night vision goggles, because they have the ability to see that IR radiation as it is emitted from a human body or an animal, or through heat escaping around windows and doors and that type of thing. So that's the radiation portion of it. Now, we talked quite a bit about kinetic energy. Let's talk a little bit about potential energy. Potential energy is, in a sense, you can think of it as stored energy, because it is energy that can be made available to do work, or to motivate a process, or move a process, or cause a reaction to happen. Now, in physics, it has to do primarily with the position of the object relative to some norm. And when that object is released, the potential energy is converted to kinetic energy. In chemistry, potential energy is due to the potential for bonding forces or of attraction, or intermolecular forces. If you remember from our bonding unit and our liquids unit, intermolecular forces are the London dispersion forces, the dipole-dipole, the hydrogen bonding that we see with discrete covalent molecules. Bonding would be metallic bonding, covalent bonding, network covalent bonding, ionic bonding, and that type of thing. Now, this is a little bit more complicated to understand for young people. And so let's see if we can unwrap it a little bit. So chemical energy is the potential energy that is made available during a chemical reaction or process in which bonds or intermolecular forces are formed and bonds or intermolecular forces are broken. Now, when we form a bond or an intermolecular force, energy is released. We would call that exothermic. Energy is exiting the system, so it's exothermic. So energy is released when bonds formed. Energy is required to break a bond. You can think of a bond as a magnet. It takes energy to pull two magnets apart. If the magnets are strong, when you're getting them close to one another, they'll actually pop out of your hands in order to get near one another. That would be the analogy to energy being released. So a force or a bond is like a magnet. It takes energy to pull two magnets apart. So that's what this little guy's doing, is trying to break these bonds, and he just hasn't had a good enough workout to do that. So you really want to memorize that, because those are key principles here. Now let's take a look. Hopefully you will get to see this in your classroom, because this is one of my favorite demos. This is the annual gummy bear sacrifice. We say that energy is stored. Now, don't let that think that if you break a bond, that energy is released. What happens is it's a relative concept of energy through a chemical reaction. So if energy that is required to break the bonds in the gummy bear is less than the energy that is released when bonds are formed as you make the products in this little gummy bear, you'll see that energy is released, and that energy could be ultimately captured, and that's why we call it stored energy. It can be released as light or heat. So we say that this is stored, but don't get in your mind that that means that that when bonds are broken, energy is released. That is not true. It's got to be a comparison of that which is broken compared with that which is formed to determine if there is stored energy available. And that can then be transformed into chemical energy, light energy, heat energy, or mechanical or electrical energy. Now, the next little segment is going to be discussing energy changes, and I'll go into more detail about that exo and endothermic that we alluded to in this clip.